howdy how there. We're gonna do one of these learning streams. We're gonna do one of these learning streams right here. Yep. You better get your butts ready. You better get that booty ready. You better hold on tight for some censored learning action. Some censored G-rated learning. Let's see how long I can contain myself. Let us begin!
To take care of defining pi yourself, Houdini just knows the value of pi. However, if you're using Houdini 16 or earlier, you have to define it manually, so what you will do is drop down.
I missed this whole thing and like how much it deviates from the original equation. So what you see on my screen is, you know, the original equation, like pen and paper style. And I'm about to, you know, go over this tutorial how to vexify it.
So let's just comment here and paste our formula. So this is the formula that we will be calculating. And this symbol here is a pi. So let's write this a bit differently. Pi times n times x times sine of pi times m times y plus b times the sine, and in the beginning this is a times the sine. Let's drag this out, it's going to be a long formula. So b times the sine of pi times m times x times the sine of pi times n times y. So this is a formula translated to how you would write this in VEX. And depending on the version of Houdini that you're using, pi is either globally defined, so you don't have to take care of defining pi yourself. Houdini just knows the value of pi. However, if you're using Houdini 16 or earlier, you have to define it manually, so what you will do is drop down float pi equals, and then either you look it up or you had someone force you to memorize it, so it's 3.14159265. That's pi, or at least its first few digits. So let's look at this formula again. Formula needs an x and a y value, and we will just use the grid coordinates for that. Set the grid to be oriented along the x and y axis like this, and we don't have to take care about just mapping those values. So let's do that. I am getting an error here because I'm trying to overwrite the definition of pi that Houdini 16.5 already has, so I will delete that. Just keep in mind that if you're working on Houdini 16 or lower, you will need to do that. Okay, so let's look at the formula again. We will plug in our x and our y coordinates at the points, and we will also need pi, which we already talked about, and then two scaling factors, a and b, for both parts of this equation that will get added, and then another two scaling factors, n and m, for the frequency of the oscillation in x and y axis. So let's define them using our trusty float sliders. Create the interface element, and we now have sliders for A, B, M, and N. And I already experimented with them a little bit, so let's set A to 1, B to minus.
Alright, so this part we're gonna just like burn on through and fast forward real quick. Oh, excuse me, did I say burn on through? Sorry, that's my trigger word. You know what I'm saying? You know what I mean, Jelly Bean? I'm talking really close to the mic. I'm talking super duper close to the mic there. I'm gonna have to turn it down a few notches. Yes, sir. I have to turn it on down. Alrighty then. Hello, my two viewers. What's up, Electrical Skateboard? Bruh, I love you, man. You're my number one. You're my number one, bruh. You never say a goddamn thing, but I appreciate you. Alright, so let's carry on, eh? Oh yeah, I gotta sort of copy and paste this. Alright, so I need to declare all my variables. That's what I'm doing. I'm declaring variables. I'm declaring variables out of these pen and paper. Are they also called variables, IRL? I think so. What is a variable, you may ask, if you don't know what I'm talking about? A variable is something that is subject to change in a fucking equation. Oh, there I done did it. We just went from G-rated to PG-13. Real quick. Well, that's where I'm going to call it for anybody who is not comfortable with this kind of language. I just might not be able to contain myself. I'm sorry, Jim. Back to you, Bob. Right. Look at this shit. I mean, it's really fucking boring. You know what I mean? I gotta swear to make this shit fucking bearable. I mean, who can do that? I
And
can't. I'm
N2,
not
say 4
I'm not the
and
person
2 for now. We can dial those
for
in
that
later. I
shit.
just don't want them to be at 0 because I won't see any effect then. Next, we can immediately drop down this formula up here. Let's just decide what we want to do with the result. In our case, I suggest writing them to a point attribute. Let's call it amp for amplitude, and it should be a float.
Sure.
So f at amp, float amp, equals.
You know what sucks? That I don't have a third window. That's what sucks. I'm about to just turn off my... Yeah, screw it, right? I'm just gonna turn off, just gonna turn off my speakers. I turned on my speakers to impress my wife, but... so she could hear my fancy mumbo jumbo, but I guess it's not really necessary.
Equals 2, and then I will just take this ginormous formula, copy it, paste it here, and add a semicolon.
Alright, so I don't really need that much gated.
Let's highlight this point here. Okay, what's going on here? Let's fix this. When we hover over this error message, we can see the tooltip saying that we referenced an undefined variable. Of course, we didn't expose our point positions x or y, so let's take care of that by going.
Dude, what is going on with my antiviral? Antiviral.
Float.
Alright, so what did he do? I missed this whole shit.
Care of that by going float. When comes formula and amp amplitude, and it should be a float. So f at amp, float amp equals 2, and then I will just take this ginormous formula, copy it, paste it here, and add a semicolon. Let's highlight this point here. Okay, what's going on here? Let's fix this. When we hover over this error message, we can see the tooltip saying that we referenced an undefined variable. Of course, we didn't expose our point positions x or y, so let's take care of that by going float x equals at p, that's our position, dot x, that's shorthand for
Maybe I should ask a question. It's time to ask a question. Very beautiful. However, I open the file to show the particles. Alright, I'm gonna ask the teacher a question. Let's ask him a question. Can I type a question?
shorthand, that's short dot p, that's our at p, that's going float x equals at p, that's our position.
Alright, so when you declared float x equals at p, how did you know
dot x, that's shorthand for
how When you declared float, how did you know that x in the equation? Of course I know. Let's see. How do you know? Of course I know that you know because you are a genius. uh can learn why the x variable in the equation equals p dot x. When you declared, this is my question. When you declared float x equals at p dot x, how did you know that x in the equation equals at p dot x? Of course I know that you know. That's kind of stupid to say. Of course I know why you know. Of course I know, like, I don't know how to say this. Of course I know you know. This is like a super dodgy fucking question. I don't know how else to ask it. I hope he understands. I'm just asking for an explanation. Maybe I don't even need to say all this. I'm curious as to an explanation. Can you explain? Alright, I'm curious. I'm curious as to an explanation. Wait, what? When you declare float x equals p, can you explain why x in the equation equals at p not x? In hindsight, the answers seem obvious, but maybe I can discover some more insight into understanding.
For accessing our positions x component. Let's do the same thing for
I
y.
can't show this.
Float
Sorry.
y equals
follow
at
along, I
p
guess, with me, but
dot
I can't
y.
show,
And
like,
if we want to be super
content.
clean, we explicitly
It's
tell
bad enough.
Houdini that p is a vector. Add a
Recording is
semicolon, and now everything executes fine.
I don't
Let's
know.
save this And let's display our amplitude value by dropping down a visualize node, go to visualizers, and we'd like to visualize our attribute as a.
Alright, I gotta go back. I got a little lost in space. Alright, so I'm declaring these variables because I just magically know. What's up, Brad, man? How's it going, dude? Sorry, I got a little distracted there for 2 minutes. I just was trying to figure out how to type something, and I didn't have my chat window up. I hope I didn't dissuade you too much, bruh, by ignoring my chat. I have a problem, like a tendency to ignore chat, but I'm trying. I'm trying to get better with it. Not much, man. Ain't much going on with me. Just trying to learn some shit while I'm unemployed right now, looking for a job. I figured I gotta stay on my toes, stay sharp. So I'm just doing some more learning. Alright, so yeah, y, blah 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 blah. Alright, so he knew magically that x and y is just points on a grid.
Visualize node, go to visualizers, and we'd like to visualize our attribute as a ramped color. Let's use the infrared preset, and our attribute should be amp. Let's wire this in here, highlight it, and we can see those patterns appearing here.
Damn, just
now
like
let's
that
try
already?
dialing in those
Holy
values
crap.
here, and we can see that.
Alright, okay. Damn, son. Alright, let's do this. I need some more. Holy crap-oly. Alright. This is pretty gnarly. I don't think it's working. I do not think this is working. Let's try these numbers. The heck? For some reason.
They start to look different.
For some reason, mine looks completely different. This is what always happens, right? For some reason, mine looks complete. Whoops. Friggin' tutorials, eh? Good old tutorials, eh? Yeah, man. Alright, so I'm gonna move along now. Let's see, I gotta figure out why mine looks different. Hey yo, equation. Why you look different, fam? Why you looking different? That mess up somewhere? First of all, it's like not even. Oh, I know why. Alright, just go back.
Let's
I got
wire
a color ramp preset. Stupid. Ramped attribute? What? Why don't I have this? Oh, the frustration, dude. The frustration is real. Alright, let's just
go to
fucking do that,
visualizers,
dude.
and we'd like to visualize our attribute as
Ramped
a
attribute, there
ramped
it
color.
is, for fuck's
Let's
sake.
use the infrared preset, and our attribute should
Ay.
be amp. Let's wire this in here, highlight it, and we can see those patterns appearing here. Now let's try dialing in those values here, and we can see they start to look differently. However, they do not exactly look like those patterns we've seen on these metal plates. So let's check what's going on here by going into the geometry spreadsheet here, and we can see our values for amp, for amplitude. And we can see they range from about 1.
You know, I hope let's see. I forgot to do something. Let's check my graphics card, GPU. Yeah, you know what? I wish someone told me, but I'm probably lagging. I'm probably lagging bad. What is this? Because I'm rendering in the background. Let's see. 55. Let's just say 55. I don't know. I don't want any hiccups. Alright, so I need to reset. Let's put this on like 30%. I'm sure it'll be alright if it's rendering at like 30%. Alright, let's try this again. Let's re-render that last frame. 55. Re-render that last frame, render to disk. Now we're rendering 30% of our GPU power. I'm not even gonna check to see if I was lagging or not for the last like 20 minutes. I'll just keep moving along. I can always check that later. So now that we have things like pretty much where we want them,
0.7 to minus 1.7. But as we already mentioned, those Chladni lines appear in areas where the amplitude is
dude, I totally missed like
about going into the geometry spreadsheet here, and we can see our values for amplitude values here, and we can see they start to look differently. However, they do not exactly look like those patterns we've seen on these metal plates. So let's check what's going on here by going into the geometry spreadsheet here, and we can see our values for amplitude. And we can see they range from about 1.7 to minus 1.7. But as we already mentioned, those Chladni lines appear in areas where the amplitude is around 0. So how can we modify our formula that instead of spitting out values of 0 where there's very little vibration, it spits out values closer to 1? Well, as we saw in the geometry spreadsheet, our amplitude goes from minus 1.7 to 1.7. And when you look at this formula here, you can see it is basically an addition of this side and of this side. So the addition is the last thing that's going on here. And when you look at these sides, again, you can see you multiply two sine waves together, and the sine of something by default will be in the range of minus 1 to 1. So both sides of this equation will be in the range of minus 1 to 1. So the lowest value when adding them simply would be minus 2, and the biggest value would be plus 2. However, what we're doing here is we scale those sides with the factors a and b that we dial in here. And thus, the extreme values of these formulas will be between minus 1.8 and plus 1.8. And we can calculate these extreme values. Let's call it like float extreme. We can calculate this value by just adding the absolute values of a and b together. So it doesn't matter if this b is minus 0.8 or plus 0.8. What matters is just the absolute value of those two values. So let's do that. The absolute value of A plus the absolute value of B. So that's the extreme. And what I can do now is use this extreme to calculate a new value for our amp. So our attribute amp will be equal to the extreme value minus the amplitude that we already calculated. So the amplitude is how strong this thing vibrates at a given position. And by subtracting this vibration strength from the maximum vibration strength, we get exactly what we want. So let's do that. Let's see what comes out here. And of course, I think we need to take into account the absolute value here as well. That is because it does not matter if the plate is vibrating downward or upward. We only care about the strength of the vibration, not the direction. And the plate can, when excited, move upwards or downwards. So by taking the absolute value of this value that our formula spit out, we cancel out if the plate is moving up or down, and we just care about the strength of the movement. That looks more like Chladni lines. Let's try dialing in those values.
It's pretty fucking true.
And we can see some patterns that look very similar to those Wikipedia photos we've seen. What we can do now are two things. On the one hand, we can drop down another point wrangle and, for example, use our current amplitude to displace the points, in this case in the z direction. So let's take our current point position and add to it a vector. And the vector should be 0 along x, 0 along y, and should have the value amp along the z-axis. Let's see if that works. Highlight this. We can see now, well, it's a bit strong, so maybe let's dial it back. like this. We can see now we have those patterns extruded in space. However, if we want to simulate those sand grains falling on this plate, what we can do is just drop down a scatter node, wire in the point triangle, and within the scatter node, check density attribute and pipe in our amplitude as a density attribute. Also, we'd like to uncheck the relax iterations, and let's increase the overall total count here. But as you see, we still have problems clearly seeing those Houdini lines. So what is happening here? Let's highlight our point triangle and head into the geo spreadsheet. And we can see when we look at the amplitude, it is now varying between 0.25 and 1.62. So what we want in the end as a density attribute for our scatter sub is a value that is only positive where those Houdini lines should appear. So the simplest thing that we could do, even before we're thinking about fitting or ramping or remapping these values, is just subtract something from it, a value, so that we are only ending up with positive values in the regions of our plate where our amplitude is biggest. So our amplitude's max
I have no idea what the fuck you just said.
value.
Let's try that again.
Only positive where those Houdini lines should have.
Alright, I have no more negative values. Was that the point of... Ayayay, kudasai, honto ni mo.
Within the scatter node, check density attribute and pipe in our amplitude as a density attribute. Also, we'd like to uncheck the relax iterations, and let's increase the overall total count here. But as you see, we still have problems clearly seeing those Houdini lines. So what is happening here? Let's highlight our point triangle and head into the geo spreadsheet. And we can see when we look at the amplitude, it is now varying between 0.25 and 1.62. So what we want in the end as a density attribute for our scatter sub is a value that is only positive where those Houdini lines should appear. So the simplest thing that we could do, even before we're thinking about fitting or ramping or remapping these values, is just subtract something from it, a value, so that we are only ending up with positive values in the regions of our plate where our amplitude is biggest. So our amplitude's maximum value is around 1.6, 1.7. So in our point triangle, after our last line, what we could try doing is just subtract some value from our amplitude. For example, in our case, let's say 1.4, and we can see now we are getting those sharper lines. Their sharpness will be even increased if we subtract even more and get closer to the overall maximum value. So the downside of manually subtracting a value just to be able to clearly distinguish those lines in the scatter sub is that as soon as I change my settings here, those lines will get blurry again because their maximum minimum value will differ. So let's use those maximum values that we already calculated up here, subtract them, and let's say we'd like to always subtract 90% of the maximum value. So instead of subtracting this constant value here, let's subtract our extreme value times 0.9. So we'll end up with sharp creases no matter what values we're going to dial in here. And now for this to look a bit more realistic, as this plate is usually vibrating, what you could do is animate the global seed. So we'll just put in $FF, so the global seed will be equal to our current frame. And when we hit play now, we can see those vibrating, oscillating specks of dust on our Houdini plate. This is one of these examples.
Dude, I fucking missed something. Because my shit's not flat. And his is flat. And I don't know why mine's not flat and his is flat. I don't know where I fucked up. But I done fucked up somewhere. I done fucked up somewhere in my code. If only he can just go go to the side. Cause I can't see anything. Whatever, man.
That show how much can be done in VEX without actually knowing much programming. Because most of the stuff we've been doing in this tutorial is actually math and not programming. We didn't have any crazy loops, any weird arrays, and absolutely no control structures. All we did is just evaluate some formulas. And this exact case is one of the reasons why I prefer writing VEX over VOPs. It would be absolutely doable of plugging these formulas together in VOPs. However, you would end up with a nightmare of a node tree compared to these few lines of equations that you write down. Equations that you don't even have to come up with yourself, as we've seen here, because we found this equation on a really neat website that was dealing with the exact same problem that we were looking for. So I hope you had fun with this slight math detour, and we will be back to programming in the next tutorial. See you then.
Alright, I just need some settings from this guy. Luckily this tutorial was only like 12 minutes long. It's not even that bad. I mean, like, frills. Alright, so I guess these... Yeah, I watched that whole damn thing without really understanding the math. Like, I don't know if I need to watch it again. Or if I should just take some fucking math classes. But, it looks like our scale is just different. We just have different... I don't remember what he made that. This is just strange, though. It's weird. It's weird that... You know... It's weird why mine looks so different, I guess. Then again, maybe I just don't need that many points. Just gonna go through these settings, make sure I got everything right. I mean, it looks so far so good, not me. Like, it seems like pretty basic stuff at the same time, like, basic and not basic. There's definitely a lot of cheese involved. It's just... I gotta see, like, you know, stupid shit, like, you know, what's his grid size? 2? Oh. Well, no wonder. 100 rows, 100 columns? What? A little addendum, too. It's like, you know... I can't tell if his is flat or not, like... But look at how much that's extruded out. It's... I have no idea if I did a lot of this correctly. I guess it doesn't matter. I should just save it. Caldani patterns. VEX Caldani patterns. Assets. VEX Cladani patterns. Yeah. We'll just go with that, huh? Alright, I'm just gonna scrub through this a little bit more, see if I missed anything like extremely important. You know, hopefully I'll have better luck understanding some of the content for the next few lessons, eh? What? Oh, cause it's times 0.1. Doi. But like, I don't know these things. You know what I'm saying? I really don't. I can make this like a function. CHF, what's it called? Like amp max, I guess. Amp max, bam. Oh, fucking amp max. Boom, 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 boom. It's really amp mult max. It's like a multiplier. I should have specified that. And now what you have is a much nicer thing. It is finished, Jace. It is finished, Jace. 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 It's kind of weird. What's it doing? Jace. 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 Alright, well, we're done here, ladies and gentlemen. Do you have to turn on multi-threading for this? Nope, it should be on by default, and it's not. Oh, okay. That was 12 minutes and $30 for the month. For me. Okay. Now let's learn about for loops.
So now that we know how to deal with variables and how to write some basic formulas in Houdini's VEX, let's talk a bit about control structures, that is, about the for loop. And I think this is best explained directly in code. So what I'm going to create here is just a single geometry, and all I'm going to drop down here is an attrib wrangle, like this. And I will set it to run only once. So anything that I put in here will be executed only once. For example, if I add a point with the help of the addPoint function, and we have to specify our position with the help of a variable, so let's create a vector, call it pos, and set it to 0, 0, and 0 for now. So that runs, I see there's this point appearing, and if I hit D, go into the geometry tab and increase my point size, I can see that a bit better, and maybe highlight the point number here. So this is the single point that I created. Also when middle mousing over this here, you can see I just created a single point. Let's create a second one.
Did I do that?
Set pos to
I did that.
1, 0, 0 this
Bam.
time,
That's
and
my
add
point.
another point.
Bada bing, bada boom.
So I now have those 2 points here, 0 and 1. When I middle mouse on it, it says I have 2 points. And I could go on forever like that. However, if for some reason I'd like to create many points, this might not be the most efficient way of just dropping down add point after add point after add point. However, there is this control structure, this construct in programming, that allows you to execute a given piece of code over and over again, as many times as you like.
That?
And the most basic structure to accomplish this is called a for
How do you do
loop.
that?
Let's just delete this. And say for some weird reason, we'd like to create 10 points at the center of our scene. So I'll have to execute this command 10 times. Let me just go here. And what I'm going to drop down is a for loop. So we're just going to write for, parentheses, then a curly bracket. Then let's go past that addPoint command and close the thing with a curly bracket. And also...
Okay, so this is how you write a for loop, ladies and gentlemen. Lettuce, turnips, ne? Danky desu ne.
What I'd like to do is use tab to indent this command here, so that it becomes clear that this command is within this for loop. And the for loop works like this. It will take a counting variable, which we'll have to initialize first, so let's do that. And a counting variable traditionally is called I, J, or K. Usually I call mine I, so let's initialize it to be 0. Close that with a semicolon, and the for loop will take this counting variable and check if a certain condition is met. So in our case, let's check if I is smaller than 10, and as long as I remains smaller than 10, it will run this command here. And also at the end of each iteration of each loop, we want to increment I. So we say I++, which is the same as if I wrote I equals I plus 1. But that's just much shorter. So what we have here is the bare minimum of a loop. Again, let me go through this. What I'm doing here is I initialize my counting variable with the value of 0. Next, I tell the for loop to check each iteration if I is smaller than 10. And if it is so, increment I by 1 and run this, what's in the loop body here, which is just a single command to create a single point. So when we execute this, we can see now, we see a point ID of 9, because that's all the point numbers are overlaid here. When I middle mouse on this, I see I just created 10 points. And I can easily increase that by just checking if I, for example, is smaller than 1,000.
Let's run that back. Hey DJ, let's understand this for loop just a little bit better. Hey, let's really get it in the brain,
and if it is
so to speak. Let's understand what the fuck is a for loop.
1.
Come on, bro.
But that's just which is increment
what the fuck is
a certain condition
anyway?
Is met. So in our case, let's check
when a
if
certain
I
condition is
smaller than 10, and as long as I remains smaller than 10, it will run this command here. And also at the end of each iteration of each loop, we want to increment I. So we say I++, which is the same as if I wrote I equals
That's the real kicker.
That's
what I missed.
But that's just much shorter. So what we have here
what can you say? What can you say? What did you say, bruh?
That's just
you could do I equals I plus 1. That makes more sense to me. You're saying that I equals I plus 1 for every iteration. I++, now that's just some like, you know, genie hoodoo shit. It's like, you know, why? Oh, you want to know why? Well, back in 1966, you know, in IBM, some guy was just like, let's fucking just put a plus plus. And then from that day forward, uh, I equals I plus 1 was never used ever again. And we just use I plus plus. Okay, well, now I know. I just made that shit up, but now I
but
know.
that's just much shorter. So what we have here is the bare minimum of a loop. Again, let me go through this. What I'm doing here is I initialize my counting variable with the value of 0. Next, I tell the for loop to check each iteration if I is smaller than 10. And if it is so, increment I by 1 and run this, what's in the loop body here, which is just this single command to create a single point. So when we execute this, we can see now, we see a point ID of 9, because that's all the point numbers are overlaid here. When I middle mouse on this, I see I just created 10 points. And I can easily increase that by just checking if I, for example, is smaller than 1,000, and I now created 1,000 points here. However, creating points just in the center of our scene is kind of boring, so let's try and create a really elaborate circle here. And you can calculate positions on a circle with the help of the sine and cosine functions. And they expect an angle between 0 and 2 pi. So the idea is here, instead of running our loop and counting just to 1,000, let's instead use it and count between 0 up to 2 pi. So what we'll need for that, instead of an integer variable here, let's create a float, call it angle in our case, and check if the angle is smaller than 2 times pi, and if it isn't, let's increase the angle.
This is some, I don't know, man. This is the part that, like, you know, starts to go over my damn head a bit.
By some really small value, say 0.01 in our case, which will add, in our case, 629 points. And let's use the angle that we just created to actually calculate the position of the newly created points. So let's create a float, call it x, and x should be equal to the cosine of our angle. Let's create a float called y.
I'll try it one more time, just because no one's watching anyway.
And let's use the angle that you...
Let's try this one more again, fellas.
So the idea is here, instead of running our loop and counting just to 1,000, let's instead use it and count between 0 up to 2 pi. So what we'll need for that, instead of an integer variable here, let's create a float, call it angle in our case, and check if the angle is smaller than 2 times pi, and if it isn't, let's increase the angle by some really small value, say 0.01 in our case, which will add, in our case, 629 points. And let's use the angle that we just created to actually calculate the position of the newly created points. So let's create a float, call it x, and x should be equal to the cosine of our angle. Let's create a float called y, which is equal to the sine of our angle.
Okay, float.
And finally, let's convert these x and y coordinates to our pos. So pos should be equal to our x coordinate, our y coordinate, and let's set it to 0 for now. And of course I misspelled angle there. So now it runs. Let's hide the point numbers, and you can see I just created
I can hear him say this like a million times, but I do not know if I will understand why. Like, I'll just keep asking why though, but why, but why, but why? Like, alright, I get you're declaring the x and the y as cosine and sine, which exists here, set x. But okay. So am I multiplying I'm multiplying the function by the angle variable, which is running the for loop. Like, this is returning the value to place. No. Damn, dude. Alright, so angle is this variable with the expression in it. I'm multiplying the variable angle with cosine and applying it to x, and then placing x on my graph in the x position. I'm doing the same with y, but instead of taking cosine times the angle, I'm taking sine, the function sine, times the angle value, and also placing that on a graph. What each of these variables return to me is a value with a value that I see here, with the value that is placed on the graph. You know, starting from 0, my first value is at xx, or is at 0. My first value starts at 0, xy 0, xy equals 0. This y, I mean this 0 value that I haven't even mentioned is because I'm pretty sure it's just like a container. Because there's no z, I have to, well, actually, no, I'm setting 0 in z space here. That's why it's flat. I could say like, oh, this is like, I don't know, maybe I could say this is z, and then it's going to be like, what the fuck is z? And then I could say, oh, z is just like, p dot z. That's all it is. Bam. I could say that like, it's, maybe I could say, maybe I could say it's maybe I could say it's x times y times the angle. See what that gives me. Now why didn't that work? Because I'm doing something I can't do that. Why can't I take the result of this and this, multiply them with each other, and but let's just take one and see what happens, huh? Nothing. I can't do it. Nope. Alright, so let's do cosine times sine. You can't do that. That's weird. Well, I knew that it would work eventually if I just, because in theory I know why it's working, but I don't know why I can't replace it with I can make this float and do all this other shit, but I can't make this float and just multiply my x and my y. Why? Because it's happening in the for loop? Now, what if I made this a let's say I did this, right? Let's say I just uh, made these float x equals this, right? And now it's a variable. Because it hasn't happened yet, right? Float at x. This is bad. This is all bad. This is just, you know what? Let's just skip that for now, huh? But if I change this to a 1, let's see what happens. Yeah, I had a feeling. That's what it was going to do. Now, it's like this is... Oh, hi. How's it going? What's up? Hello, Oran. Thanks for following, bruh. I really appreciate you. Feel free to, ask me questions or teach me something about math. I would appreciate it. If you have any experience with like C#, C++, this coding language called VEX, which is like an embedded language in the software, it's based on C++. So, if you know math and all that shit, you might know more than me with some of this syntax stuff. Math, I said. I mean, like computer programming, if you know that. I'm just playing around. So I'm assuming that the set function already recognizes like point position. I'm just replacing like, all right, watch. If I have 0, 0, 0, I knew it. So I'm just setting a point in space. Setting a point in space at the coordinates that I specify, either x, bam, or y, bam, or z. I could type any number, and it moves 5 units along in space, because that's the input that I put there. So what else is next? Let's see. Moving on.
Complicated and finally subdivided circle. However, if I switch off my point display and maybe scale back my point size to something smaller, you can see there's no connection in between those points. So let's fix that by first creating a new primitive, and we also want the primitive's number, so let's create a variable, call it new prim for new primitive, and this should store the primitive's number of the primitive that we are going to create with the help of the addPrim function, and we want to create our primitive on our primary geometry stream. That's the stream with the ID 0, and we can tell it to create a polyline. If I go to the help menu of addPrim, you can see it just takes in the geo handle, which is 0 in our case, and as a type it takes a string, and if we scroll down here, these are the types that we can create with addPrim. And I just created this polyline here, which is just a line. Okay, so after we created each point here, let's add it to this newly created primitive with the help of addVertex,
polyline.
Let's drop down the parentheses and highlight our function call and hit F1, and we can see this takes 3 arguments.
All right, bruh. You're going way too ahead of me here.
The parentheses.
Just give me a minute. Just give me a minute, okay? I'm doing all these things. I'm multitasking like a butterfly, stinging like a bee. Okay? Do you know what I'm saying, man? Do you know what I mean, man? Integer new prim, let's name it polyline.
And highlight our function call and hit F1, and we can see this takes 3 arguments, our geo handle, which should be 0, our primitive number, which is stored in the variable new prim, and our point number. So we haven't got a point number here, however addPoint will return one if I just drop down an integer variable in front of it, call it new pt for new point, and set it equal to the point number that will be returned by addPoint here. Okay, now I can complete my addVertex. It's on our current geo stream. We want to add the vertex to our newly created prim, and we want to add our new point to it, like so. So if we zoom in now, we can see this is a solid line here, even with those points highlighted. Good. However, this circle is quite boring, so let's make it look a bit more interesting by introducing some multiple.
It's like, I get what he's doing here. I still don't know why, but whatever, dude. I just have to finish writing this code. Why don't you? Oh, new pot. New pots, new pots. Alright, I've seen this before, when someone creates like a line, create line, curve, create line. When someone creates like a line primitive, you have to do it like this. Polyline is the, I don't know, man. He pressed add 1, went to add prim, and like somehow he found it highlighted his. Anyway, this is the same thing that I'm doing that he did. So integer add prim, geo handle 0. I don't know why. String type. Maybe this is your. You can call it whatever you want, but in this case, we're referencing the polyline function, something like that. It does what it was written to do.
For the angles here, and as I want to be able to,
let's get a little more explanation on that. Maybe he can
down and our
some
complicated and finally subdivided circle. However, if I switch off my point display and maybe scale back my point size to something smaller, you can see there's no connection in between those points. So let's fix that by first creating a new primitive, and we also want the primitive's number, so let's create a variable, call it new prim for new primitive, and this should store the primitive's number of the primitive that we are going to create with the help of the addPrim function, and we want to create our primitive on our primary geometry stream. That's the stream with the ID 0, and we can tell it
primary geometry stream.
Create a polyline. If I go to the help menu of addPrim, you can see it just takes in the geo handle, which is 0 in our case, and as a type it takes a string, and if we scroll down here, these are the types that we can create with
okay.
And I just created this polyline here,
types.
Which is just a line. Okay, so after we created each point here, let's add it to this newly created primitive.
So polyline, open polygon, this is what it does. I can make all sorts of shit. I mean, I wonder what would happen.
With the help of add vertex. Let's drop down the parentheses and highlight our function call and hit F1. And we can see this takes 3 arguments, our geohandle, which should be 0, our primitive number, which is stored in the
Wait, what did he do?
number 0, this F function call and hit F1. And we can highlight. Let's drop down the parentheses and highlight our function call and hit F1. And we can see
Highlight our function. What?
add vertex. Let's drop down the parentheses and highlight our function call and hit F1. And we can see this takes 3.
Oh, that's cool. Just works just like that. I just gotta like highlight it a little bit. Holy fucking shit, the resources, dude. Oh my gosh. F1 for more help. Just wait for that little sucker to pop up. And then bada bing, bada boom, you got resources and references. I mean, this is blowing my mind. Like, for 6 fucking years, you couldn't do this shit. I mean, what am I saying? All the way up until maybe 6 years ago. Maybe sooner. Maybe like 3 years. Maybe 1 year. I don't know. Maybe they just added this in 16.5 that you can just sort of like hover over things. Maybe it's been in there forever. I do not know, but that makes my life so much easier. So much easier.
3 arguments, our geohandle, which should be 0, our primitive number, which is stored in the variable newprim, and our point number. So we haven't got a point number here, however, add point will return one if I just drop down an integer variable in front of it, call it new pt for new point, and set it equal to the point number that will be returned by add point here. Okay, now I can complete my add vertex. It's our current geostream. We want to add the vertex to our newly created prim, and we want to add our new point to it, like so. So if we zoom in now, we can see this is a solid.
Alright, you did these things. You added the vertexes. It's a handle to the geometry to write to. Currently the valid value is 0, which is the self of the geo, which means the current geometry in a node. Thank you, Houdini. Thank you for that explanation. This argument may be used in the future to allow writing to other geometries, if you want to access other inputs of other streams. Okay. Moving along now.
Line here, even with those points highlighted. Good. However, this circle is...
I got lines and shit!
So let's make it look a bit more interesting by introducing some multipliers for the angles here. And as I want to be able to dial those in, let's create 2 sliders for them. Let's call one F1 for frequency 1. And let's create a float slider called frequency 1. Create that. And I see I just created this float slider here. Let's just copy this, paste it here. Call it F2, create the slider as well, and then add those multipliers down here into the formula, so it's the cosine of our angle times F1, and down here it's the cosine of our angle times F2. So let's dial this up a bit, and we can see now this is yielding weird results. However, if I dial up both, you can see it gets a bit more interesting. And also, let me just go into the edit parameter interface, and for both of these, let's dial up the ranges a bit, like so. And now I can really generate more interesting patterns here. And those patterns are
called... Give it an input. I fucked up.
Here, let's just copy this, paste it here, call it F2, create the slider as well. I
space out so easily.
Add those multipliers down here into the formula, so it's the cosine of our angle times F1, and down here is the cosine of our angle times F2. So let's dial this up a bit, and we can see now this is yielding weird results.
So familiar,
however, if I dial up both, you can see it gets a bit more interesting.
I feel like
and
I just
also,
can't do it on my own
into
yet.
the edit parameter interface,
like,
and
I need
for both
some
of
hands.
these, let's dial up the ranges a bit, like so. And now I can really generate more interesting patterns. And those patterns are called lissajus.
I need someone to hold my hand. Lissajus. 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 C'est la vie, mes amis. Swan swan, swan sway, swan 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 sway, sway sway swan swan swan, swan 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 sway. Mes amis, oui oui, mes amis. Okay, I'm done.
Figures. I think I'm mispronouncing this. So if we've got any French listeners or French-speaking
This is cool
listeners,
as
drop
fuck.
us a hint on how to pronounce this name. And you might have seen those figures on classic
I've seen this
oscilloscopes. It's
somewhere.
one of the
Yeah,
easier tricks you can
oscilloscopes.
play
Is
with
that what
them.
it is?
However, when I move my viewport around, you can see the whole
Sexy.
thing is flat because we're only taking care of 2 dimensions here. So let's add a third dimension by first creating a third slider.
Third dimension.
For a
Can I get
third
some
frequency.
Craigasms in the chat for the third dimension?
Create the slider
Please?
and also add its parameter interface.
Please?
And then down here, calculate a z value.
Alright, I fucked up again. I'm not listening. I'm fucking paying attention. Should I play music? Can I get some like kappas in the
By
chat
first creating
if I should
a
like
third
play
slider
music or something?
for a third frequency.
Let's get that third dimension rocking.
Create the slider and also
Create
add
that
its parameter
slider.
interface. And then down here, calculate a z value with the help of our
Alright.
trusty cosine function.
This shit, like, I'm
Again,
not gonna
angle
front. This
times
shit is
f.
super boring, which is why, like, I would love to just make it funner, and I am trying my damnedest to make this better for myself and others, but I can't do it alone. No, I can't do it alone. I'm busy coding, can't you see? That is why I need your help. Should I play music or like, would that help?
3.
I mean, it is like sort of an extra thing to DJ. Not really. Not if I can just get the right, like, get it out of the way with the right volumes. Get my nice playlist going. Nah, me.
And down here, instead of a
Okay.
0, let's set our z component
let's just
to a z
fucking
value.
call it Z.
And now what we can
Let's
do
just
is
call it the
increase
fucking
that
Z
frequency as
that
well,
we made.
so we get some.
You know what? I was about to do that. I was about to do that when I was understanding how this shit works. Was that the last tutorial? I don't remember. It don't matter. What really matters, I think it was this one. Yeah, I was talking about, yeah, I remember the circle and everything like that. What really matters is I tried to fucking do this shit and it didn't work. And there's probably a reason why it didn't work. Let's make this, what's the default, eh? Was it like 1? Hold on. There's a reason it didn't work. Because that's what I did. I did this. I did this myself. I do kind of understand it. I do know what I am doing. I knew it. I knew what I was doing. This happens to me all the time. God damn it. Maybe it's my age. I don't know. But I did not expect to get that if I just fucking hooked it up to a ramp. That is all he did that I did not do. I just added... Oh man, now I want to go back and do something like, instead of doing this, which I didn't have to do, I could have just took this that I had before and I could have just said like CHF, bam. CHF. And then if I did that, it would have been the fucking same. It would have been the fucking same. But I did not think of that. I did not think outside of my little fucking box, man. So what I should do from now on, I'm gonna fucking do it. I swear to God, I'm gonna do it. I'm gonna do it all the time. I'm gonna make sliders out of everything because putting a constant value in a parameter ain't gonna tell me shit. I'm just like, you know, it's much more static. It's much more narrow-minded. I'm not seeing the bigger picture. It's like living in a two-dimensional world, okay? I'm not seeing the third dimension because I'm not putting sliders on shit. That's all I gotta do, bruh. That's all I gotta do, bruh. Just put sliders on shit. Throw fucking, you know, just throw like these kind of numbers on it. Like throw time parameters on everything, maybe. Bam. Time. Too much time. Not enough time. Too much time, not enough time. Need more time. Let's try that. Oh my god. That is just sick titties. I guess there has to be something that's like static. Geez, now it's getting gnarls. Point one? Ah, there we go. That's pretty cool. This thing is weird though. I should just make this like constant thing. It's pretty nuts. It's science. I'm sciencing some shit. You know, it gives some pretty cool like animations. I had a feeling like if I did some math stuff, I could find some, you know, I could probably like write it to chops or I don't know. Just do something extreme with it. Alright, I'm gonna stop playing with my math. Just trying to understand it is all. Just trying to understand my maths, bruh. Just trying to understand some maths. These curves are too damn thin. There we go.
More interesting patterns going on here. Also, what we maybe want to do, we're only running this from 0 to
I don't even know why
2
I had to
pi,
declare all
and
this.
that's a bit too
I didn't
few
even have
iterations
to-
for these ends to actually
I didn't
meet
even
up
have to do
again.
that.
So instead of having this maximum iterations values fixed, let's just drop down a fourth slider, again a float. Let's call it max iter for max iterations.
It's a little convoluted.
Create that slider again.
It's kind of strange.
Instead of
like,
checking if
you know,
our
they
angle
skim over
is
some things
smaller
that are
than
really
2 pi,
interesting,
let's
but then
check
they
if it's smaller
convolute
than
things
maximum
that
iterations. And also,
little
in our
pointless,
parameter interface,
maybe.
let's increase the range a bit.
Fuck do I know?
So now we can dial this up,
Where did
and
you
we
put
can
that
see
shit?
this
I
figure
replaced max
emerging
iter.
there. Quite interesting, actually. In order to give this some depth and some
like-
geometry,
Like
let's use
that.
the
Like what the fuck?
polywire sop.
What does that mean? He just skimmed over that shit. But we spent like, you know, he's like, I don't know, man.
In order to give this some depth and some geometry, let's use the polywire.
Gotta go back. I'm just gonna look at the code, like, fuck it, right? Alright, so if this is greater than max iter, okay, if the angle is greater than, oh, for each angle greater than 0, right, for each angle greater than max iter, angle plus equals that. Whoops. Let's keep my animation on at A. It's almost like a speed function, I guess, but it's increasing the maximum iterations of the for each. Okay. It's trippy, man. It's cool though.
Quite interesting, actually. In order to give this some depth and some geometry, let's use the polywire sub. Let's just wire this up and highlight it.
Polywires
We can see now we
on
have
it.
some geometry.
Let's call this for each. I think it's just for loop practices.
That visualizes these figures. Some more interesting settings that I found were like frequency 1 is 3.04, frequency 2 is 1.5 I think, and frequency 3 was 3. Not really. Yeah, of course I mixed those two here, so that should be 3 and that should be 1.5 like this, and I had an iterations count of 48. So I really like this somehow. And you can dial this in and just go all crazy about it. The takeaway from this, and the thing I want you to realize, is this construct here, the for loop. So anytime you're going to run through something multiple times, which happens often when you're writing algorithms, the for loop is the most simple control structure that you can use to do that. So let's go over this one more time. What a for loop does, or what we have to do in order to make a for loop work, is first specify a counting variable and initialize it. In our case we called it angle, and we told VEX to start with a value of 0. Then we need to drop down a condition that has to be met in order to continue executing our loop. So kind of the opposite of a stopping condition. And here we can continue our loop as long as the value of our angle counting variable is smaller than the value stored in our variable called maxiter. And if this is the case, we will execute the loop body and increment our counting variable by this value here. So let's go.
Jesus.
Loop angle need to drop down
that whole part.
Is this construct here, the for loop. So the is the iterations count of 48. So I really like this somehow. And you can dial this in and just go all crazy about it. The takeaway from this, and the thing I want you to realize, is this construct here, the for loop. So anytime you're going to run through something multiple times, which happens often when you're writing algorithms, the for loop is the most simple control structure that you can use to do that. So let's go over this one more time. What a for loop does, or what we have to do in order to make a for loop work, is first specify a counting variable and initialize it. In our case we called it angle, and we told VEX to start with a value of 0. Then we need to drop down a condition that has to be met in order to continue executing our loop. So kind of the opposite of a stopping condition. And here we can continue our loop as long as the value of our angle counting variable is smaller than the value stored in our variable called maxiter. And if this is the case, we will execute the loop body and increment our counting variable by this value here. So let's go through this manually for a few loops. So we start off with an angle value of 0. And a value of 0 is smaller than our current maxiter value, which is 48. So we will execute this loop here. We will calculate our x, y, and z position using an angle value of 0. Then create a point at this position, and at this point...
Maybe I should hear it one more time.
This construct here, the for loop. So anytime you're going to run through something multiple times, which happens often when you're writing algorithms, the for loop is the most simple control structure that you can use to do that. So let's go over this one more time. What a for loop does, or what we have to do in order to make a for loop work, is first specify a counting variable and initialize it. In our case we called it angle, and we told VEX to start with a value of 0. Then we need to drop down a condition that has to be met in order to continue executing our loop. So kind of the opposite of a stopping condition. And here we can continue our loop as long as the value of our angle counting variable is smaller than the value stored in our variable called maxiter. And if this is the case, we will execute the loop body and increment our counting variable by this value here.
I think I
So
sort of
let's
said
go
that.
through this manually for a few loops. So we start off with an angle value of 0, and a value of 0 is smaller than our current max iter value, which is 48. So we will execute this loop here. We will calculate our x, y, and z position using an angle value of 0. Then create a point at this position and add this point to our polyline. Then we are increasing our angle value by 0.
So that is connected to that, which is connected to that, and that is just 12. If I just wrote like 12, it would be the same, but it wouldn't change because it's just a slider.
0.01. So now our angle has a value of 0.01, which still is smaller than our maximum iterations number. So we're going to calculate x, y, and z again, now with an angle value of 0.01, create a point, and add this to our polyline. Again, we are going to increase our angle value by this amount here, so we now have an angle of 0.02, which is still smaller than our maximum iterations value. So again, we're calculating x, y, and z for an angle value of 0.02, create a point, and add this to our polyline. Again, increase our angle value to 0.03 now, which again is smaller than our maximum number of iterations. So again, we calculate x, y, z, this time using an angle value of 0.03, create a new point at this position, and add it to our polyline. And so on and so forth. This is the loop body. It is good practice to indent the code you're writing here with the help of tab in order to visually identify your loop body in an easy way. Also, if you're transitioning to Python at some point, Python actually uses indentation to structure the code. In VEX it wouldn't matter, however Python really uses this as a functional part of the programming language. So it's a good idea to train this from the beginning. And there are many cases in which you want to use loops, and one of them is working with arrays.
Like that too. Bam. It's all making sense. I am going to bathroom break. BRBs. Peeps. Yeah. Maybe I should put on like a little music for this. I mean, I'm not going to be long anyway, but oh well. Young DJ Smokey.
Smoke gang, trailer boys are creeping through your hood.
Trailer Park Boys creeping through your hood.
Positive squad, stay blessed, never stressed.
Home chef bitch, fuck the monkey over. Run the key head since the walk in the soda. Mono burger shorty off the 305 told you. Chum bucket nuts in your monk, then I fold you. Quack the damn bitch up and shit like a soldier. Extra strong mid ball game on Jehovah. Jeans in his tongue on your bitch like a motor. V12 sauce on your clip, fuck the odor. Oh, you got to know damn well that I'm a floater. Beat the monkey red till the walls all swole. Oh, you got to know damn well that I'm a floater. Beat the monkey red till the walls all swole. Oh, you got to know damn well that I'm a floater. Beat the monkey red till the walls all swole. 6 to the top of my jaws all closed. Still a dog and so my balls all swole. Krispy Kreme soft, how I form when I'm older.
Alright. Since the music started, I'm probably just gonna leave it.
Orange bowl water, fruity sauce in your vulva. A bitch you mean and I, a bitch you mean and I, a bitch you mean, a bitch you mean, a bitch you mean and I bet you see me now, I get you creamy now, I stretch the way we stretch your pussy.
As soon as you come into this stream, you already know what it is. you already know what it is, though. Did I finish that shit?
To structure the code. In VEX it wouldn't matter, really idea to
I guess I
and
did.
there are many cases in which you want to use loops. So now that we know how to deal with variables and how to write some basic formulas in Houdini's VEX, let's talk a bit.
That's just trippy, man. It's just some trippy shit. Alright, let's call it for that one. Yo, smoke it. Represent my smoke it. I am smoky. Represent smoky. Smoky. Represent smoky. What? They didn't, what? What? Check. This shit didn't work. Shit's not working. Why you ain't working? What? Hey. What? It's just not working. That's so weird. I can't type like that. It shows up on Restream, but I can't type it on Restream. It's fucking dumb. It's fucking stupid. Alright, moving along. Arrays and for each loops.
So last time I've been mentioning that one case where you want to use loops is when dealing with arrays. So what is an array and how does it work? Well, the kind of old school analogy is that your array, and in our case it's called my array, is a box in which you have index cards. Index cards that can store one value that's written on them, and they have an index, starting with 0 for the first card. Here is how these individual elements would be called. The array name, my array, the elements that are stored within the array, in this case 3 elements, the index of each element, starting with 0, and the value that's stored within each element. So in a more compact form without the analogy, this is what we're usually dealing with. An array which has a name and which has elements. In our case, 6 elements, with each element having its respective index, starting from 0, and a value it can store, in this case integer values. And the way you'd access an array's element is with this syntax here. So you could read out the array's second element by calling the array, then have these square brackets, and within those square brackets you just put down the index of the element whose value you'd like to read. Similar here, where we're reading the value from...
Oh shit, I fucked up. Alright, I got like 3 more videos to watch. These are pretty long. I don't think I need to go over the whole thing because I did half of this. Let's see, so I got
array and
I got arrays and for each loops, if statements, custom functions. I'm gonna try to do as many as I can until my wife
my array, so let's fix that like this. Let's store some values in our array, and there are different commands for dealing with arrays. The
Let's put some values inside of these.
most basic 2 commands are push and pop. So push adds an element at the end of an array, and pop removes an element from the end of an array. So let's try that out. Let's type in push and parentheses, and then I'm just going to open up the help page for push. So we can see this adds an item to an array, and it first needs the array and then the value it should add to the array. We want to add to my underscore array, and let's add a value of, say, 11. We can see now the array that's stored on my point now has this single value in here. So let's add a few other values. Like so. Let's drag this out here, and I can see my array has now 5 elements, 11, 22, 33, 44, and 55.
Alright, so before we get all fucking crazy here, let me just make this, let me just type out this shit. All this mumbo jumbo. All this mumbo jumbo hootenanny. Random ass numbers. Spreadsheet. What is it? What is this shit? What's this shit?
So let's drop down another pointer angle here and try
I don't even know what that.
accessing
I don't
another
see it.
elements 11, 22, 30.
I don't see it. I don't see it.
3, 44, and 55. So let's drop down another pointer angle here.
Why don't
Type
they
my array,
work though?
and I can see my array has now 5
Mine don't got
Here's-
shit. Actually, you know what? This is probably just stupid. It's probably just a stupid ass bug. Because I have no points. Gotta add a point. Now I have arrays stored in my point. That's all I need. Alrighty
back
then.
this out here, and I can see my array has now
Moving
5
along.
elements 11, 22, 33, 44, and 55.
They're
so
in there.
let's drop down another pointer angle here and
Alrighty
try
then.
accessing those values. So
Let's-
first
let's
let's create
access
a
them.
variable in which we load the array from the point. So
Let
again,
us
int, let's call
access
this one my array
them.
2, and
And
this one needs
my
curly brackets
array
here to tell
equals-
VEX that it's an array. And we want to load in this our integer array that's stored on my point called my array, like so. Nothing happened yet, so let's try accessing the value, and let's create a new integer, call it val for value, and it should be equal to my underscore array, and let's access element with the ID 2. And of course it's still not my array, but my array, like so. And we have our value here, and this is our array, this is the value. So ID 0, ID 1, and ID 2. That's the value that we just loaded from the array and saved it into our val. Also, just to be sure that we see if we modified the array by this operation, let's save it back. So again, I
That's pretty neat.
square brackets at
No.
my underscore array equals my underscore array. And we can see we haven't changed the array yet. However, what we can do here, instead of just using this simple access by ID, I can use the pop command. And again, let's just go to the help page. So pop in its simplest form just removes the last item from an array and returns it. So let's just give it the array where we want to remove the last item from. And we can see now our value equals to 55, and it's not stored in the array anymore. Let's try this a second time. Call this one val2, and again call pop in exactly the same way. We can see now we have only 3 values stored in my array, but value 1 is the 55 and value 2 is the 44. So pop always
I get it.
removes
You're-
from the
you're-
end of an
you know,
array.
you're taking 'em
However,
out,
you
you're
can
moving 'em
also
around
tell
and
it
shit.
to remove a given index. So I can call pop
Oh,
with
boy.
2 arguments, the array name and then the index where it should remove.
It's probably like. Let's see.
Something from the array.
I gotta
So
look
let's
this
call
shit up
it with a 0, so it'll in theory remove always the first element. And it does exactly that. First, with this one here, we remove the first element from our array, which is the 11, and then again we remove the first element, and as the 11 has already been removed, the first element in my array now is the 22. So just so you can see this is my array with only one pop command, so 11 has been removed from the front, stored into my val. And this is the second call of pop. So now again the first element has been removed, stored into my attribute called val2. Also there is a
Did
whole
anybody else
subsection
get
in
that?
Houdini's help dealing with arrays. So there are lots of hints and lots of techniques for working with arrays, and also for commands that you might often use when working with arrays. So I've been telling you that arrays kind of work hand in hand together with loops. So let's try this out and just copy those 2 pointer angles over here, and let's just highlight the first one here. And instead of writing push 5 times, let's instead
Slice it.
create a loop to fill this
all
array.
there.
So let's create a for loop. And the first thing we always do in a for loop is declare and initialize our counting variable. So int
Besides
I
creating all your brackets and
equals
shit.
0. And let's decide how long we want to run this. Let's say as long as I is smaller than 9. And let's increase I by 1 each iteration. And in here, I'm just gonna do push my underscore array, comma, I. like so. And of course this needs a semicolon. And now I can see I've filled my array with all those values coming in from my iterations here. So we're starting off with 0, and as long as I is smaller than 9, we continue running this loop, so we go from 0 to 8. Let's just store all the numbers from, say, 1 to 20 in this array.
Okay,
so let's
back.
start with 1 and check if I is smaller or equal to 20. And as long as that condition is met, fill the array with the current value of I. So I have this
Smaller
array
or
of
equal
20
to.
values here, ranging from 1 to 20.
That's good
Let's,
to
in
know.
the second point wrangle, sum up all those values in here. And
Wait a second. Cause I'm not popping shit, that's why. Alright, I gotta keep going here. Wait, what? What the fuck? Oh, I fucked up.
sum
I just
up
realized
here
where I
of
fucked
20
up.
values here.
That's this. I done fucked up.
Here, ranging from 1 to 20. Let's, in the second point wrangle, sum up all those values in here in this array. So I still have those two pop commands here. Let's get rid of them, like this.
Oh, okay, buddy. Okay, buddy. Hold your horses, buddy. Okay, buddy.
And
Hold your horses.
again, let's create a for loop, which goes through each element of the array and sums it up. And in this case, it's pretty straightforward, as we know this array has 20 elements. So let's again create a for loop, which will run 20 times. So we initialize I to 0, as long as I is smaller than 20. Let's keep incrementing I, so this should run 20 times. And just to check, let's set a value on our point to the elements value that we currently extracted from our array. So curly brackets I, like this. So we can see now when this runs, it stops at the last value. It extracts from the array, which is the 20, so it'll run through.
Alright. And finish. Why does it return 9?
All of these elements. So let's just go over some value. It extracts from the array, which is the 20, so it'll run through all of these elements. So let's just go over what we did here. We loaded in our array, which was stored as an attribute on point, then created a for loop that runs from 0 to 19, which is exactly the IDs that we have. Keep in mind, we start with ID 0 here for the first element, so the 20th element will have the ID 19. And then we extracted the element with the current loop's counting value as an ID. So in the first loop, we extract the ID 0. In the second loop, we extract ID 1. Third loop, we extract ID 2, and so on and so forth, until we end up at ID 19, which has value 20. So everything is fine here. So
I don't know
to
why
sum those up,
at
let's,
0.
outside of the loop, create another variable, call it sum. And
Why did I start at 0? Probably because that was 0? I don't know. Makes
and
sense.
initialize it to 0, and
Alright, let's try this again. Int sum.
in here, let's say sum plus equals the current array number. And down here, after we summed up all of these, let's create another attribute, in this case call it sum, and it should be equal to the value that we just stored in sum. So we can see now that all these numbers here summed up is a value of 210. Again, we initialized a sum variable
but like
with 0.
it's pretty over my head. It is pretty over my head. That's, you know, I'm not gonna, just because I got it, it doesn't mean I know what the fuck it means. Alright, it's a function. Didn't know that. So sum is a thing that returns the sum of the vector's component. this case, plus equaling my array integer values for each step iteration thingy.
And then for each iteration we
Something
read
like
out
that.
the current element of our array and add it to our previous sum value, and after we iterated through all these elements we write out this sum to an attribute here. So this was kind of straightforward, as we know
Okay.
exactly how many elements are in our array. But let's create another example. So add a second point here, and in our point triangle here we can see we have both points storing the same array with the same length. But instead of giving it a fixed length here, let's create a new variable called maxIter for
I got 2 points.
max iterations, and
Let's create some more things.
it's an integer, and it should be a random number generated from our current points number. And let's multiply this by 20 and add 1 to it. So it'll be between 0 and 21. And put that down here. So our loop runs maxIter times. We can see here in this case, for the first point it runs 9 times, for the second point it runs exactly once. And we can dial this in by adding a seed value here until we have something that we like. For example, like this. So 2 elements in the first array, 11 elements in the second array. And that is kind of problematic down here. In this case, it will yield the exact result, because even if we're trying to access elements that are not here, VEX will automatically return a 0. However, there might be algorithms in which it is important that you only iterate through an array as long as there are elements in this array. So here we are trying to extract 18 elements out of this array which are not there, and here we are trying to extract 9 elements out of this array which are not there. So how would you go about extracting those elements and going through this array so that no cycles are wasted? Well, what we first want to do is, after we loaded this array in here, we want to determine how many elements has this array. And we can use a function called len for that. Let's create a new integer, call
I
it
can't even say
num_elem for number of elements, and it should be equal to len. And then we put down our array name into parentheses behind it. So this will return the number of elements stored in this array. And then what we can do is use this number of elements to tell Houdini that it should only execute this loop exactly as often as there are elements in our array. Like this. So nothing should have changed here. We still can see we've got the sum here, but this time we are only running the loop 2 times for this array and 11 times for this array here. And yes, there are other techniques of iterating through an array, and we will talk about them in a future tutorial. But for now, let's stick to that. So let's actually build something using these techniques. Again, create a new GeoNode, dive in there, and I'm going to drop down a grid onto which I will scatter some points. Say 100 for now, and let's disable the relaxed iterations so they have this kind of erratic placement here. Next, I'm going to drop down a point triangle, wire it up, and in my code, the first thing I want to do is, for each point, I want to look which points are close by, and I'm going to use a function which we use very often at Intagma. It's called nearPoints. So what nearPoints does is, it looks at your scene and determines which points are within a given distance to the point that you are working on, and it will return those points as a list of point numbers as an array. So let's create our array, call it npts for nearPoints, and the curly brackets to tell VEX that it's an array. And in this array, we want to store all points that are nearby, and we find them with the nearPoints function. Like this. Again, hit F1, go into the help menu, and we can see there are several ways of calling this function. Let's start with the simple form here, so it needs a geometry stream that is 0 in our case, just the geometry coming into the first slot. Then it needs a position from which we want to search for nearby points, and a maximum distance within which we're going to search for points. So 0 for our current geometry, the first input slot here, then v at p, just the current point's position, and then a maximum distance. Let's call this one maxDist and create a variable for this, a float that is, call it maxDist, and it should be equal to what we set with the float slider. And we call the float slider maxDist as well. Just create the slider here, scroll down a bit, and we can see now we have this neat flow slider here. Let's set it to 0.15. And just for debugging reasons, I'm gonna write out my array storing the points nearby. this. So let's head over to the geo spreadsheet here, and we can see, well, we always only find 1 point. That is, maybe my maximum distance is a bit too small here, so let's increase that a bit and see what happens. So we can see now we are getting more points. And when I look at this array, there's something interesting happening. So for the point with the point number 0, it also finds the point itself, and that is because we are only searching from a given position within a given distance, and we are not including or excluding any point numbers here. And this is one of the caveats when working with near points. It will always also return the current point number that we are working on. And in this case, it'll only find the point itself and no actual neighbors. And while this can be handy in some cases, what I want to do next is draw lines between those points. And drawing a line from a point to itself does not really make sense. So let's clean this up and just remove those points by just always removing the first element in an array. And we can either do this with pop or with another command called remove index. Doesn't matter which one we use. Just so you see in it, I'm going to use remove index here. And I want to remove from NPTS always the first element, that is the element with the index of 0. So for some points we now have an empty array, they just didn't find any points nearby within this given distance here, and for some points we have like 5 neighbors, and so on. Okay, now that we have this list of neighbors, let's create a for loop, and as you can see in the geo spreadsheet, the arrays are very different in their length. So some have 0 elements, some have quite a few. And to deal with that, let's again use a technique we already seen. So first let's create an integer, call it max iter for max iterations, and it should be equal to the length of the array that we just created. That means the number of elements in the array. So length of NPTS after we remove the first element, and then drop down this for loop. And then what we want to do is, we would like to read out the value stored in the array at the current counting variable's position. I'd like to call this npt for near point, because we're now extracting a single element from npts near points. So near point equals npts curly brackets I. And now all I have to do is add a primitive to our current geostream. It should be a polyline, and it should go from our current point, that's the one with ptnum, to this point that we just extracted out of our array. So npt, like this, no errors. Let's go to the scene view, and we can see some connections happening there. And when we dial up the distance now, we can see new connections appearing there, like this. So far so good, that seems to work. However,
Alright, I gotta watch that whole part again. Because he doesn't explain it.
And then what we want to do is, we would like to read out the value stored in the array at the current counting variable's position. I'd like to call this npt for near point, because we're now extracting a single element from npts near points. So near point equals npts curly brackets I.
Square brackets.
And now all I have to do is add a primitive to our current geostream. It should be a polyline, and it should go from our current point, that's the one with ptnum, to this point that we just extracted out of our array. So npt, like this, no errors. Let's go to the scene view, and we can see some connections happening there. And when we dial up the distance now, we can see new connections appearing there, like this. So far so good, that seems to work. However, it sometimes is a bit clumsy to extract each array's length and then put that down into a for loop here, just to be able to iterate through an array's elements. And luckily, VEX has another construct for doing this in a bit more compact way, and it's called a for each loop. So let's just duplicate this point triangle here and use that one to demonstrate the for each loop. So let's just copy those two lines here and paste them down here, and I will just comment them out for now and delete all that here. So when you are using loops to go through a list,
You know, it would be pretty cool to like trace. Like create geometry. You see like the geometry being created. That's a lot of math. I might not be ready for that. I was gonna say, like, you know, you see the geometry being created and like it creates like shapes, triangles and stuff, like three-dimensional polygons that fall. And maybe not
of
yet.
elements, there's another way how we can write that. This
Okay.
time with a for each loop.
So he just did that whole thing and I gotta redo
So
it.
it is kind of similar to a comment them out here and paste them there. Just each one
I kind of missed that last part. Come
for
on.
each loop. So let's just duplicate this point triangle here and use that one to demonstrate the for each loop. So let's just copy those two lines here and paste them down here, and I will just comment them out for now and delete all that here. So when you are using loops to go through a list of elements, there's another way how we can write that. This time with a for each loop. So it is kind of similar to a for loop, however
Alright, for each loop.
it only takes two arguments. One is an integer, in our case let's call it npt, then a semicolon, and the other one is an array, npts, like this. And what for each will do now is, it will go through this array, npts, as long as there are elements. And for each iteration, it will load a single element from npts into this variable, npt. So in our case, this loop will step through our list of points close by and just successively load each element from our npts array after the other. And now that we've done this, we can just take this bit of code here and paste it in our loop, delete these comments here, and that should yield the same result. Let's check. Yeah, exactly the same result. However, when you compare our classic for loop with our for each loop, the for each loop is way more compact. So that's what I tend to use when iterating through an array. So this is kind of the bare minimum that you need to know to be able to work with arrays. And most of the time we will use arrays to store point numbers of points nearby or neighboring points.
I heard something outside. What the hell is it? I hear some shit outside. They having a concert? They playing Rick Astley outside. Rules and so do I.
That means points connected to our currently active point, and so on and so forth. Now, the way I set up this piece of code here is I can specify the maximum distance within which we will be looking for points to connect. But what if I want to set a minimum distance as well? Well, for that we need another control structure.
What? What? Alright, let's just call this one. This ain't Rick Astley. I'm tripping. It's Michael Jackson. For each loop. Down, down, down. I only got two more to do. Only 2 more tutorials. We did some for loops, we did some for each loops, we did some if statements. No, that's what we're doing now. Now we're doing if statements.
So the final control structure we need to talk about is an if-else block, which we'll be using to check if a certain condition is true or not. Just a basic example of what we're going to do. Let's drop down a GeoNode, dive in there, and use the add sub to add a single point. Next, let's drop down a point wrangle, and on here just initialize an attribute, call it out. It should be a string, and it should be empty for now. Let's head over to the geo spreadsheet and check. Yeah, empty string, called out. Alright, let's append another point wrangle, and in here let's first...
Hold on, buddy. Hold on, buddy.
And in here
Why
let's
you go
first
so
define
fast?
3 variables, and
Why are you going so
empty
fast, buddy?
initialize an attribute, call it out. It should be a string, and it should be empty for now. Let's head over to the geo spreadsheet and check. Yeah, empty string, called out. Alright, let's append another point wrangle, and in here let's first define 3 variables. Let's call them A, B, and C.
Define those variables.
Let's set A to 5, B to 6, and C to 7. Okay, let's assume for some reason we want to check if B is bigger than A, and only then do something. The way we're going to do it is with an if statement. So we're just going to drop down if, then our parentheses, and then our curly bracket, similar to our for loop structure. And in the parentheses, we will write an expression that Houdini will then evaluate. And if this expression evaluates to true, so if this expression is met, then Houdini will execute the code block that's within the curly
Resident
bracket
Sleeper.
here. So let's write down an expression, and we want to check if B is bigger than A, and if it is so, let's set our string out to true, like so. Click outside here, and we can see our string is now set to true, because B in our case is bigger than A. 6 is bigger than 5. Okay, let's set B to 4 in our case. We can see now this expression here evaluates to false, so this code block here is not executed. However, it bugs me that this out attribute is just empty. So what we can do in this case is we can use an else statement, which just goes below this curly bracket here.
You're really killing me, man.
Just write down else, and then again curly brackets. So we now extended our if block so that we check this expression here, and if it's true, we will execute this code block here, and if it's not true, we will instead execute this code block here. So let's write in here, our attribute out should in this case be set to false, like so. We can now see our output string is set to false. So this is the very basic structure of an if-else block. And as you've seen, you can use the if statement without the else statement, but you cannot use the else statement without an if statement. However, what you can do is you can combine the else statement with another if statement. So first we want to check if B is bigger than A, which in this case is not true, so we'll go to this else here. And in this case, we can now check again if, for example, B is bigger than C, which should evaluate to false. And we can see now this code block also does not get executed. And of course after this we could drop down another else, and so on and so on. So you can combine these else blocks with another if to build more complicated decision trees, decision structures. But for now let's get rid of that. And let's again look at this expression here.
It's not even working for me, dude. Like, I've seen this before, but... it ain't returning shit. It ain't returning a goddamn thing. What'd I do wrong?
91 and of course executed. And of course after this we could drop down another else, and so on and so on. So you can combine these else blocks with another if to build more complicated decision trees, decision structures. But for now let's get rid of that. And let's again look at this expression here. So what I can do is I can check if something is bigger than something else, if it's smaller than something else, if it is exactly equal, which we're going to do with those 2 equal signs. So now these numbers have to be exactly the same, which they are not currently, so let's just set them both to the same number. We can see now this evaluates as true again. And we can also
The fuck? If B equals A? Oh, whoops. Here we go.
combine expressions. So let's set our variables to 4, 5, and 7 in this case again. And let's first check if B is smaller than A, which is false. But let's also check if maybe C is bigger than B. And the way we can do this is with logical statements. And the first logical statement is the OR statement, which is these two vertical dashes. So we'll check if either B is smaller than A or if C is bigger than B. We can see now this evaluates to true because one of these conditions is met. It doesn't matter which one is met. In this case, it's the second expression here, but this one is true, so the whole block here gets executed. This is an OR statement here. So this lets Houdini check if any of those statements is met. And we could add a few more, so we can also check if maybe C is exactly equal to B, and so on and so on. And this logical combination of expressions here is just evaluated left to right. So this one is evaluated first, then this one, and then this one. And if any of those is met, the whole block here will be executed. So that's the logical OR. However, there's another operator. So in our case, let's first check if B is bigger than A. But we also want to check if C is bigger than B, and only if both conditions are met. We want to execute this code block here. The way we do that is with a logical AND, which is those two ampersands. So we want to also check if C is bigger than B. And we can see now the first expression is true, and also the second expression is true. So this one here gets executed. Let's just try to negate this. So now we check if B is bigger than A, which is true, and we also want to check if C is smaller than B, which is not true. And in order for this whole expression to become true, both sides here have to be true, which is not the case anymore. So let's check, and we can see now this evaluates to false. So this is the logical AND operator, which means that all of the expressions that I combine with the AND operator have to be true in order for the whole expression to become true. So let's get rid of that here. And the last thing I want to show you is kind of a shorthand. So if you have an if statement whose code block is only one line, you can omit those curly brackets here. And same goes for the else statement, and it'll still evaluate, and evaluate correctly. Let's just check. Yeah, still works. So this is kind of a shorthand. If you have only a short expression and only want to execute one line of code after you checked your statement, you can just do that. Okay, back into our previous setup. Let's do that.
Okay.
Okay, back into our...
Let's just call this if-else example.
previous setup. Let's just delete this one. You know, this was the clumsier one. So let's just go with the for each version here. What we want to do now is check not only if the points we're looking up, the near points we're looking up, is within a certain distance, but also if it has a minimum distance to the point from which we're looking. So let's create a new slider.
Catch up with you in a minute, homie.
This expression.
That looks right.
Back into our previous setup. Let's just delete this one. You know, this was the clumsier one. So let's just go with the for each version here. What we want to do now is check not only if the points we're looking up, the near points we're looking up, is within a certain distance, but also if it has a minimum distance to the point from which we're looking. So let's create a new slider. Call it mindist for minimum distance. should be a float value. Let's call it min underscore dist. Create the slider, and let's set a minimum distance of 0.4 for now, and we can change that later. So the maximum distance is already checked when we're looking at those points. And in order to check if the points have a certain minimum distance, I'll just do this in this for each loop where we draw the polyline here. But before we draw the polyline, let's first get the distance from our currently active point to the point that we want to draw the polyline to. So let's create a float, call it dist for distance, and it should be equal to the distance between my currently active point position and my point position from the point NPT. So let's get that first. Create a vector, let's call it npos, and it should be equal to the position of my point that we're currently iterating through. Like this. So we can now calculate the distance between our currently active point position and the npos, that is the position of the target point. Let's check. Okay, no errors so far. And now what I want to do before I draw this line here, I want to check if the distance that we just calculated is bigger than our minimum distance. Like so. And only if this is true, we want to execute this add prim here. So in this case, we could use the shorthand, and let's increase our minimum distance here, and we can see now the closest connections don't get drawn anymore as we increase the minimum distance here. Alright, so far. Let's extend on this a bit, and just for demonstration purposes, let's create a box and append the points from volume.
Where'd I fuck up? That's where I fucked up. And then, where else I fuck up? I wasn't even paying attention. I have no idea what he said.
Is
Try that
within
one more
a certain distance, but also if it has a minimum distance to the point from which we're looking. So let's create a new slider, call it min_dist for minimum distance. Should be a float value. Let's call it min underscore dist. Create the slider, and let's set a minimum distance of 0.4 for now, and we can change that later. So the maximum distance is already checked when we're looking at those points. And in order to check if the points have a certain minimum distance, I'll just do this in this for each loop where we draw the polyline here. But before we draw the polyline, let's first get the distance from our currently active point to the point that we want to draw the polyline to. So let's create a float, call it dist for distance, and it should be equal to the distance between my currently active point position and my point position from the point NPT. So let's get that first. Create a vector, let's call it npos, and it should be equal to the position of my point that we're currently iterating through. Like this. So we can now calculate the distance between our currently active point position and the npos, that is the position of the target point. Let's check. Okay, no errors so far. And now what I want to do before I draw this line here, I want to check if the distance that we just calculated is bigger than our minimum distance. Like so. And only if this is true, we want to execute this add prim here. So in this case, we could use the shorthand, and let's increase our minimum distance here, and we can see now the closest connections don't.
It's like so simple, but it took me so long, and I figured it out on my own just by looking at it, but like he doesn't explain it simply, like, and I do this all the time, but I'm just saying, could be simpler. Like, I would just say that this is how you find the distance. Because you take v at p by the npos that we created here, and we're comparing npos to the vector p in the first input. So whatever is in the first input, we're going to compare the distance between the first input and npos for each point. Maybe that sounded just as bad as him. That's me making sense out of something just explained to me by someone who I am saying explains things overcomplicatedly. Anyway, moving
Distance here, and we can see now
on.
closest connections don't get drawn anymore as we increase the minimum distance here. Alright,
I
so
see
far,
that.
let's extend on this a bit. And just for demonstration purposes, let's create a box and append the points from volume. Highlight this here and maybe scale up the box
Probably help if I like flip these two suckers up and down just like that. Bit, eh?
a bit. Points
So what are you doing, man?
from volume.
Creating
Highlight
boxes.
this here and maybe scale up the box a bit.
Creating
So say
boxes
10
and
by
shit.
10 by 10. And in the points from volume, let's increase the point separation to dial back on the point density a bit, like so. And let's just copy over this point triangle where we connect the points and let's highlight it. And also let's dial down the maximum distance and the minimum distance to 0. And we can see we now get this regular structure of these interconnected points. Let's add another control for that. That is the maximum number of points we want to look up. So again, let's in this case create an integer, call it max pt, and it should be equal to an integer slider.
Hold up. What the fuck did you just do? I don't even know, says Samwise Gamgee. I don't even know Frodo. Frodo Schmaggins. Alright, bro.
Let's call it max underscore pt underscore num. Like so, create the slider. In our case, let's set it to maybe 5. And in our near points function, when I highlight it, hit F1, I can see I have the option of calling this function here with a maximum number of points it should look up as a last argument. So let's do that and just add our max pt number back here. And we can see now we can dial in how many points.
Bro, what are you talking about? I wasn't paying
Maybe
attention
5,
for a while.
maybe 5.
Let's go back a bit. Hey,
Distance to 0, and we can see we now get this regular structure of these interconnected points.
copy and
Let's
paste
add
it.
another control for that.
Those
That is the
points.
maximum number of points we want to look up. So again, let's in this case
I'm just like tripping out because I've never seen this quality of my viewport sucks right now. This viewport looks like shit. I don't know why. I should see like all sorts of nice not this shit. Not whatever that is. I feel like it has to do with my GPU settings, 3D viewports. Man. Oh man, I feel like the thing is fucked up. I remembered before, but I don't remember anymore where it goes. Maybe they don't even have it anymore in this sort of thing. Just didn't mean to do that. Just wanted to see it on dark. Maybe that. Nope. I used to get like such better line detail. Anyway, moving on.
create an integer, call it max pt, and it should be equal to an integer slider.
Alright, this is how we're doing the things, I guess. This script is getting big. What's next? Alright, we got min, max, max, min. Shit, he just made that. Okay. Max PT. Some dank new content right here, bruh. Some dank new shit. Alrighty.
Let's call it max underscore pt underscore num. Like so, create the slider. In our case, let's set it to maybe 5. And in our near points function, when I highlight it, hit F1, I can see I have the option of calling this function here with a maximum number of points it should look up as a last argument. So let's do that and just add our max pt number back here. And we can see now we can dial in how many points we find, which is already yielding some kind of interesting structure here, especially like this here.
Alright, so I need to create this input. Pretty interesting. It's strange, but you know, it's hard to see on my end.
And maybe let's randomly delete some points here in the volume. Let's do that also with the point wrangle. And for each point, let's just generate a random number. Let's use our trusty old rand function, just feed it the point number here, plus some sort of seed. So let's just go with the 1, 2, 3 here. And we want to check if our random number, which is randomly between 0 and 1, so if it is smaller, say 0.5, then let's just remove the point we're currently working on. So again, let's hit F1 on remove point, and this takes 2 arguments, our current geostream, which is the 0, and the point number it should remove. So 0, comma, at btnum, like so. We can see now we randomly deleted about half of the points here, which looks a bit more interesting. However, what bugs me are those diagonal connections here. So let's update our connect points here, so that it will only connect points in a rectangular fashion. And how do you do that? Let's look at this two-dimensional case. So point are. Let's update our connect points here, so that it will only connect points in a rectangular fashion. And how do you do that? Let's look at this two-dimensional case. And what we want to allow are connections like those here, like the blue one. And what we want to restrict, not allow, is connections like the orange one here. And also we want to allow connections like these here. So what's the difference between those blue connections here and the orange one? Well, for the blue connections, only one component of the position, in this case the y component, and in this case the x component changes. However, for this connection here, the point position changes both in x and y. So the point's position vectors, x and y components, both change. So what we have to do is we have to check if the difference from our target point and our currently active point only changes in one component, be it x, y, or z. And as soon as this difference changes in more than one component, we don't allow connections.
What up, Squirt? A Sierpinski curve could connect all the points at once. I wish I knew what that entirely means. I mean, I know what like a Sierpinski curve is. It's like a L system, right? Sierpinski curve. It's like an L system. Is it? I fuck up. I spelled that wrong. I've seen it before. Oh yeah, this is like the Koch curve stuff. I can actually get like, there's some custom things in there, in here called the L system. So if I like take a line, and then if I look at my line, and if I, oh, I don't need the line, I could just do that. Anyway, values, functions. So what this does is this creates like, takes the math of the Sierpinski, I don't even know how to say it. It takes like the math of it and it creates you know, similar shapes, but I don't really remember how to use this thing. I'm trying to like, there's a way to make Koch curves like right out of this thing, but you need like a certain value for it. Number of variables, and like I just don't remember. There's like rules and shit. Like if I take out some of these rules, flip them around, you can like add rules. So if I actually take, no, I could probably do this. I could probably take this thing and find like the rule. I could probably take the equation. I could probably take this whole thing and make it, but I would have to like replace these variables. That would be interesting. I could copy and paste this code into here, and sort of get like something similar. But the only drawback about that is, let's see, is that I have to like rewrite everything. Like it doesn't know what A is. Like I have to recreate all these variables. Like, it doesn't know what A is, doesn't know what Y is, doesn't know what B is. I have to make like float A, float B, float Y, or position X, position Y, integer mat. I need to declare this. I need to declare this. This would be interesting to do, like to take some code like this though and convert it to VEX and just see if it works. There's some things that this program might understand, like square root. Yeah, square root. So if I took like, oh well, it's not SQR, it's SQRT. So like if I took SQRT, now this would be proper. Shit like that, I probably have to rename all that. It would be cool though to, yeah, it'd be cool to do like sometime. Like I wonder if I can actually get that working. But anyway, moving along there.
So the way I'll do this is I will first delete those two statements here, and after I looked up my target vector position, I will build 3 float variables.
I'm trying to make this as like not resident sleeper as possible. For some reason my music stopped.
Let's call it xdist, ydist, and
Alright,
zdist.
bro, you need to slow down. You need to slow down, bro. I have no idea what you're doing. Alright,
and what we want here is we want to have the difference between our currently active points x position and our target points x position. However, we do not care about the sign, so we do not care about if this difference is negative or positive. We just want to have its absolute value, so let's take that, just using the abs function, like so. Let's copy this line, paste it 2 times, and change it, so we'll calculate the y distance and z distance by subtracting the y and z components respectively. And now we're gonna write a nightmare of an if statement. Let's drop it down like this. So we want to draw this line only if one of those components is bigger than 0 or bigger than a very small threshold. So let's check first if our xdist is smaller than our threshold, and let's take a very small number, say 0.001 here. And if our x distance is almost 0 and our y distance is almost 0, then let's draw this primitive. Let's just check if that works. Okay, now drawing primitives along one axis here, but also we want to allow this primitive to be drawn if only the y distance and the z distance are close to 0. So let's drop down a logical
Hopefully
or,
I'll be able to
so this
explain
code
this
will be
shit
evaluated either if this condition here is
after
met,
I
or
do this.
if the condition I'm just going to drop down now is met, so y distance is close to 0 and z distance is close to 0. Again, this yielded another axis here, and let's add the third axis again with our OR statement, and finally want to check if x and z are close to 0. So xdist
Jesus.
smaller than 0.01 and zdist smaller than 0.01. And now we've drawn all those connections in all 3 axes, omitting those diagonal connections, also when we're cranking up the connection point number here.
Holy
okay,
hell.
we now have this kind of Borg cube structure here, and that's 1/2 of the...
That was... Shut up. This thing keeps going off, dude. Alright, if x distance is greater than... No, is less than 0.001 and y distance is less than 0.001, or y distance is blah blah blah, or... Okay, so it's just variations of every variable that I declared with an x, y, or z distance variable, which contains an absolute value of the vector p, x, y, or z, the point in space x, y, or z, or the point in space's position in x, y, and z. The difference, we're taking the difference of the point in space, difference between the point in space and npos. What is npos? npos is a vector that I declared containing a value of the nearest point. So the input is the point and its neighbor. The input is not the point because we deleted the point. The input is the point's neighbor. So originally we take the point and the point's neighbor, then we delete the original point, only keep the neighbors. Those values are stored in NPTS. This is the array that we created where those values are stored. So we're taking those stored values that we clamped out with min and max distance, and then we're finding the difference between the original position of, or no, we're finding the difference between the absolute value of the point position. That's a hell of a mouthful to say, but like I think I'm like 90% there. Like I see the connections, literally and metaphorically speaking. I see the connections. I see where things are integratable with the for each loop. Fuck lames. Anyway, I can't. I'm not 20. All right, I don't know this fucking song. I'm not 20 anymore. This song's fucked up. Fuck flames. Lames. Alright. Is it working though? Did I do it?
Setup that we need to render this tutorial's intro video. And the other part is a subdivision algorithm that we're going to build in the next tutorial.
Alright, I don't even know if I did what
now
he
we've
did.
drawn 0.01. And now we've drawn all those connections in all three.
Oh, because I didn't fucking... What? I don't even know. I don't even know if this is working or not. Oh, my kid's home. Ripperonis. Rip the stream. Alright, so... I'll probably just finish this one. Well, it's already finished. I got one left. Just figure out
Three
this
axes,
last
omitting
part.
those diagonal connections. We're cranking up point number here, point number here. Okay, we now have this kind of Borg cube structure here, and that's one half of the setup that we need to render this tutorial's intro video. And the other part is a subdivision algorithm that we're going to...
Alright, but I'm just saying.
Is close to the other, and let's add the third axis again with our 0, so x dist 0.01.
I just gotta see
and
and press enter, see if
z-dist
anything changes.
smaller than 0.01.
Hi, baby.
And now we've drawn all those connections. We've drawn all those now
They
we've
were
drawn
already drawn.
0.01. And now we've drawn
Oh, wait. For some reason, like, it was already working for me. I don't even know. That's not supposed to be working right now. It's so weird. I gotta fix this before I peace out. I gotta find out where I fucked up. Vote X dis, Y dis. Pause X, Y, Z. B at P, X, Y, Z. X dist, Y dist. X dist, Y. Wait, what? I fucked up. That's where wait, no, I didn't fuck up there. Y dist. Easiest. Well, we got the same
And now
thing.
we've drawn all those connections in all three axes, omitting
That's
those
all that
diagonal
matters,
connections, also when we're
right?
cranking up the connection point number here. Okay, we now have this kind of Borg cube structure here, and that's one half of the setup that we need to render this tutorial's intro video. And the other part is a subdivision algorithm that we're going to build in the next tutorial.
Alright, well, I'm gonna kill the stream here. It's been real. I appreciate everybody coming through to sit through this boring ass creative stream. What else? Yeah, I appreciate you guys coming through to sitting through this boring shit. I hope, you know, if you're watching this on YouTube, or, you know, most likely not Twitch, but if you ever do catch this on YouTube, you know, feel free to drop a line in the comment section asking questions or pertaining to anything that I'm doing here, or if you would like to see me doing something, like specifically, if you have any ideas for just anything that you'd like to learn or anything that you're interested in learning, feel free to drop a line. And that's it. I'm gonna go take care of my kid now. Hopefully dinner will be ready soon. Cheers.